Mycotoxins chemical source associated food aflatoxins trichothecines. Ochratoxin A. Ergotalkaloids. Fuminizins. Patulin. Xaralenone. Aspergillus flavus and Aparasiticus. Mainly Fusarium. Penicillium verrucosum aocraceus. Claviceps purpurea. Fusarium moniliforme. P. expansum. Fusarium spp. Corn, peanuts, green nuts, milk. Cereals and other foods. Wheat, barley, corn. Rye, barley, wheat. Corn. Apples, pears. Cereals, oil, starch. Mycotoxins are poisonous substances produced by fungi, and have caused outbreaks of mycotoxicosis in humans and in livestock. Many outbreaks have been linked to eating moldy food and feed because of food shortages or because of ignorance of the possible consequences. Such practices continue in many parts of the world. Mycotoxins have also been implicated in many chronic diseases, including cancer. Public health officials are beginning to recognize the impact of these toxins on human and animal health. The Food and Agricultural Organization, FAO, has estimated that 25% of the world's food crops are contaminated by mycotoxins. In Asia and Africa, a study estimated that 10 to 50% of crops are contaminated. In a Japanese study of fusarium toxins in corn from widely separated countries, only a few samples were free from contamination, minimum water activity for growth of toxigenic molds. Aspergillus aocraceus. Penicillium verrucosum. Aspergillus flavus. Fusarium moniliforme. Stachybotrys atra. 0.78. 0.79. 0.80. 0.87. 0.94. The production of mycotoxins depends on environmental conditions, such as temperature and humidity. In addition, factors such as pH, presence of competitive flora and conditions of stress, drought and insect damage, can influence mold growth and hence toxin formation. Target organs of some mycotoxins. Mycotoxin target: aflatoxin liver, ochratoxin a kidney, trichothecines mucosa, ergotalkaloids peripheral vascular system, xaralenone urogenital tract. Aflatoxins are carcinogenic for all animal species studied, including man. Aflatoxins and hepatitis B virus are co-carcinogens, with increased risk of liver cancer if both factors are present. Ochratoxin A causes kidney damage in humans. Trichothecene exposure in humans produces a variety of symptoms, including dermatitis, cough, rhinitis and hemorrhage in the nose, but immunosuppression is the underlying cause. The trichothecene T2 was responsible for the deaths of tens of thousands of people in Russia from 1942 to 1947, due to its buildup in grain left in the field over winter. Fuminizins in corn are probably linked to throat cancer in parts of China and Africa. Ergotalkaloids, besides their historical notoriety for their acute effects, continue to be a concern because of other possible vascular effects. Xaralenone is structurally similar to diethylstilbestrol, DES. There are a number of unanswered questions about the effects of estrogenic substances in food. Regulatory limits for mycotoxins in foods. Limit, microgram/kg. Commodities. No. Of countries. Aflatoxins B plus G. Aflatoxin M1. Ochratoxin A. Deoxynivalenol. Patulin. Xaralenone. 0 to 50. 0 to 1000. 0.05 to 1.0. 1 to 300. 1000 to 4000. 20 to 50. 30 to 1000. Corn, peanuts. Other foods. Animal feeds: milk, dairy, rice, corn, barley, beans, pork kidney, wheat, apple juice. All foods: 48, 21, 17, 6, 5, 10, 4. Many governments have established limits for mycotoxins, particularly aflatoxins, though such limits should be based on scientific risk assessment of the toxicity of the mycotoxin and estimates of likely exposure. Risk assessment data are incomplete for many mycotoxins. Thus, most established limits for mycotoxins are based on good agricultural and/or good manufacturing practices. The Joint FAO/WHO Expert Committee on Food Additives, JECFA, is using human epidemiology studies to develop a quantitative risk assessment of aflatoxin. Risk assessment for mycotoxin in foods. Aflatoxin B1. Patulin. Ochratoxin A. JECFA benchmark: 0.01 to 3 cancers per year per 100.000 people per g of aflatoxin B1 per kilogram BW/day. 0.4 g/kg BW/day. 0.1 g/kg BW/day. JECFA has established provisional tolerable intakes of 0.4 g/kg body weight per week for patulin, and 0.1 g/kg body weight per day for ochratoxin A. JECFA has also reviewed the use of zeranol as a xenobiotic growth promoter in cattle and has established an acceptable daily intake of 0 to 0.5 g/kg body weight. Based on epidemiology studies, the 49th JECFA in 1997 established potency estimates for aflatoxin B1 in the absence and presence of carriage of hepatitis B virus. The risk of liver cancer increases by a factor of 30 when combined with carriage of hepatitis B virus, which is particularly common in Asia. The Codex Alimentarius Commission has not established international limits for mycotoxins, although several are being developed, for example for corn, peanuts, milk. Regulatory limits for aflatoxins in some Asian and Pacific countries. Country limit: μ/kg. Commodity: Australia/New Zealand, China, India, Japan, Malaysia, Philippines, Singapore, Sri Lanka, Thailand. 15 T, 5 T, 20 B1, 30 B1, 10 B1, 5 B1, 35 T. Absence: B1, 30 T, 20 T. Peanuts. Other foods: maize, peanut, all, rice, other grains, coconuts, peanut products. Export. Permitted levels of aflatoxins vary greatly within Asia, often depending on whether the country imports or exports the affected commodities. While overly strict regulation can be costly, the cost of aflatoxin-induced hepatocellular carcinoma can also be significant, particularly where there is a high prevalence of hepatitis B virus carriers. It should be noted that most European countries have established levels of 5 micrograms/kg for aflatoxins, while the USA uses an action level of 20 micrograms/kg for total aflatoxins. Source: Mycotoxins in Human Nutrition and Health. Directorate General 12, Science, Research, and Development, European Commission, 1994, Worldwide Regulations for Mycotoxins 1995, a compendium, FAO Food and Nutrition Paper 64, FAO, Rome, 1997. B1 equals aflatoxin B1. DE equals total aflatoxins. Limit of detection is around 10 g/kg. Chemical hazards in food. disease, and death. Toxicity. Since every chemical can be toxic to humans, it is not surprising that there are many potential hazards. While the food supply is demonstrably safe most of the time, sporadic outbreaks of food poisoning caused by chemicals tend to be magnified by the media. Food authorities must respond to these incidents while keeping safety priorities in perspective. Better risk assessments, requiring improvements in both toxicological and exposure assessments, are needed for chemical hazards. This requires epidemiological studies and better understanding of the mechanisms of chemically induced diseases. Of course, the first line of defense is surveillance of the food supply to assure that exposure to chemical hazards does not exceed safe levels. Severity. Exposure.